Hi, today I've got another project that I wanted to show off. This is a little bit of a change of pace, but it's something that I got working a little bit recently, and I just felt really good about that and wanted to do a little bit of a show and tell. So you might remember a couple months ago I did the music generator for my 6502 breadboard computer, and it was using this board. This is just a completely digital sound generator. It's an oscillator and some counter chips. It can do square waves, and that's about all it can do. But it was interesting, and it was able to play recognizable songs. That also got me thinking about other ways of generating electronic music. And I've always been a big fan of old analog style synths. And so I kind of went looking online to find some resources about how to build that sort of thing, and there is a ton of information out there. It's absolutely wonderful. So, first a disclaimer. What I'm showing off today, I didn't design any of this. These particular three components that I'm going to be demonstrating came from designs from videos by Moritz Klein, and I'll link to those in the description. They're really good videos. He does a great job explaining how all of the analog circuitry works and why it does what it does. And that was interesting to me because analog electronics is something where I don't have really any experience. So a lot of this has been new to me. But what we have to show today is three things. This is a VCO, that's a voltage-controlled oscillator, a VCA, which is a voltage-controlled amplifier, and this is an envelope generator. So let me start with the oscillator. This is the part that just generates a tone. And in this particular version, it can do sawtooth waves, or it can do square waves. You can change the frequency. It's got a coarse and fine adjustment, and for the square waves, you can also change the pulse width, which can let you change sort of the quality of the sound. So let me turn the volume up and demonstrate that. So this is the sawtooth. And then this is the square wave. And that's the effect of the pulse width change. Oh. If the potentiometer doesn't come loose. And that's the trouble with doing stuff like this on a breadboard. This, of course, is the amplifier, and it's an amplifier. It's the part of the circuit that controls the volume and makes it go to 11. So just one knob here. And this is the envelope generator, and what an envelope generator does is that it controls the volume over time to give you something that starts and stops instead of just a continuous drone. So, right now it's just doing a very start, stop, on, off sound. But the envelope generator takes its output and feeds it into the amplifier, and that's why it's called a voltage-controlled amplifier. And we have a bunch of potentiometers here, which we can use to change the quality of the envelope, the shape of the envelope. And if you've ever looked into how sound generation, like on the Commodore 64 SID works, for example, it uses an envelope generator that has settings for attack, decay, sustain, and release. And that's basically the same thing that this circuit does, although it uses the same value for both the decay and release. So let's try to twiddle the knobs and see what we can do. So this one is the decay/release, and if we increase its value, Now when I let up on it, it gradually tapers off instead of just stopping. And if we change the attack a bit, now it has a gradual start. And if we keep the attack fairly sharp, but we turn down the sustain, we can get sort of a sharp, more of a ping sort of sound. There we go. That's starting to sound a little bit more musical. So what can we do with something like this? Well, so it's voltage controlled. The oscillator has a control here. We can feed a voltage into it that will control the pitch of the sound. And the amplifier is being voltage controlled right now by the envelope generator. The envelope generator also has a voltage input. So we have two things that we could hook something up to maybe produce some more musical sounds. And I have something that I can demonstrate with this. I'll need to move things around and set up for just a moment. Okay, so I have a keyboard here that can generate the voltage control signals that the envelope generator and oscillator are expecting, and that means that when we press a key, we can get a sound. Now, one of the problems here, of course, is A, I'm not actually any good at playing keyboard, and B, I've only very, very approximately tuned to this. But you have to start somewhere. So, apologies to John Williams and Wendy Carlos on that one. But maybe with practice I'll get a little better. So anyway, that's a start. Where can we go from here? So there are a lot of upgrades and improvements that we can make to this. Just for starters, I want to make this a little more stable. So I'm using 9-volt batteries to run this. It requires 2 of them because it uses positive and negative voltages, and that's because the op amps that are used in a number of places in each of these circuits require both positive and negative voltages. And that's different from something like the Project 65 computer that just runs on 0 and +5 volts. So I need a different kind of power supply. And I've ordered a PCB that will let me build something that should run this without having to plug batteries in and take them out all the time. And that'll be nice because I've already plugged in one of these cables backwards on one occasion and blown up an op amp. So we'll be better off with a better power supply. There are also a few substitutions I've made when building this because I didn't have the necessary parts. For the VCA, it uses a differential amplifier design, and that expects some of the resistors and transistors that it uses to be very closely matched with each other, sort of a symmetrical design. And mine are not. These are 5% tolerance resistors, so it would be good to replace those and get it a little more synchronous. That might improve the sound quality a little bit. In the long run, I'd like to get some of this off of breadboards because, as you saw before, it's easy for things to get disconnected with all these moving pieces that you're twiddling with. So I might do that with kits. I might do that with designing some PCBs of my own because I do need some more practice at that. So we'll see where that goes. And there are other components that we can add to make this more interesting. A filter, for example, would give me a lot more options about changing the way it sounds. And I think I have most of the components that I would need to build one. So that might be something also that I do in the very near future. Longer term, I've been thinking about possibly building a sequencer. There is a sequencer in the keyboard also that I could use. But I think building my own would be a lot of fun. There's a lot of different ways you could go with that, both in analog and digital sort of approaches. And then there's also the possibility that I could find a way, since these are voltage controlled, to hook it up to the Project 65 computer. And I'm not sure how much I want to go that route, but it's an interesting possibility. You could turn the P65 computer into a music player or into a sequencer or a tool or something like that. So there are all kinds of possibilities, and I'll definitely be doing some more with this project in the near future, kind of alongside a bunch of the other Project 65 stuff that I'm currently working on. So that's where we are with this project, and we'll see where it goes from here. Thank you all for watching.